to the last question of Jan 2012 Core 1. The last question is circles. I'm going to go straight into it. So I've got to express this equation given that this is the circle equation. So first thing I'm going to do is I'm going to do the x brackets first. So it's going to be x, and I'm going to half this number here. So x plus 7 squared plus, and again I'm going to do the y bracket, and I'm going to just half this number here. So minus 5 squared. Now I've got to work out what my actual r squared is. So I've got to keep the 49, so plus 49. I've got to get rid of this 5 squared, so minus 25, and that's equal to 0. These two cancel out, boom, boom, move that over. So the final answer is x plus 7 squared plus y minus 5 squared, and it's equal to 25, but they want it as r squared, so it's going to be 5 squared. If you do not have a squared number on this side, you've gone wrong somewhere. Hence, part B, write down the coordinates of the center. It's just value, swap the sides. So the coordinates for this is minus 7 and 5. Oh, sorry, center. Radius of the circle is just going to be 5. And check this out. You get, oh, sorry, I thought that 2 marks was for this and this. Sorry, I thought this 2 marks was for that, and this 2 mark was for this. So it's just 1 mark each. The second 2 marker is actually sketch the circle. So the circle looks like this. And again, don't draw the circle first, draw all the points in. You know one of the points is minus 7 and 5. So it's going to be minus 7, so somewhere down here, and 5. So I'm going to put a dot here. And I'm going to label it as well, minus 7 and 5. Next, you want to look at your radius and look to see if that number is anywhere here. That number is in the y coordinate. So that means that it's going to touch the x-axis. And I've not actually drawn this properly, so I need to move this slightly. You can't do this in the paper, but I can do it right here. So that's fine. So it should look more like that. Yeah, so it's going to touch here because the radius is 5. So it's going to look like this, really. Whoa, that's not a circle. Yeah, that's a circle. It's the most perfect circle in all of existence. That's it. Move on. There's only 2 marks, so that's it. D. Whoa. A line equation has a value of y equal to kx plus 6. Okay. Show out the coordinates or the x coordinates of any points of intersection in a line and circle satisfy the equation. Bloody Nora. Alright, first thing I'm going to do is I'm going to substitute this into here. So it's going to be x plus 7 all squared plus kx plus 6 minus 5 all squared equal to 5 squared. And now all I'm going to do is just expand everything out. That's pretty nasty, actually. And there's only 2 marks. What's happening here? Alright, it's there must be a quicker way. And there is a quick way. Substitute into this equation. Don't use that one, use this one. The reason why I said, or the reason I'm stopping is because check this out. I'm doing a quadratic here, and looking at that answer there, that's going to take me ages to get to. So I've done something wrong here. And what I've done wrong here, or what I'm not doing correct, or being efficient about, is I'm not using that equation up here. So let's stop, let's rewind. X squared plus y squared, but y is now kx plus 6 squared plus 14x, and then minus 10y, or minus 10 times kx plus 6, and then plus 49. Now I can't fit that in, so I'll write up here. So now I can expand this out. So expand this out. So I've got x squared plus k squared x squared. Oh, Jesus Christ. Plus double 6. What's double 6? 12. 12kx. And then plus 36. Then plus 14x. I'll put it here. Plus 14x. And then I've got to do minus 10 times this. So minus 10 kx and minus 60. What the heck's this? What was that? I'll get rid of that. And it's plus 49. Notice how, just to save myself some thinking time, I've written all the x's together. I've written all the numbers together. So that might help me with a little bit. For this top bit, I'm going to factorize x squared out. So it's going to be 1 plus k squared. Actually, just because they put k squared first, I'm going to do it other way around. So it's going to be k squared plus 1 times x squared. So I could have put the 1 first, but just because they put the k squared first, I just want to save myself writing it out twice. I need to collect all these together. Just because this one is not a common term of this one and this one, I can only do 12kx minus 10kx. So that is plus 2kx, and then it's plus 14k, sorry, plus 14x, and collect all the numbers together. So 36 minus 16, that gives me 20, plus 69. I can factorize this, so I can factorize x out, so it's 2k plus 14 x plus 69. Again, k squared plus 1 x squared, and that's equal to 0. And let's double check it. There is kinda. What they've done is they've factorized 2 out of this, so they've done 2k plus 7x plus 69, etc., etc. So yeah, there it is, and that's 2 marks. Jesus. I hate to see what the rest is like then. Part 2. The equation has equal roots. Show that this is equal to that. So this is to do with discriminant. B squared minus 4ac. And more importantly, that's equal to 0 if it's equal roots. So now you've got to find out what a, b, and c are. A is going to be this nasty thing, k squared plus 1. B, equally, it's going to be this nasty thing here. I'm going to multiply it out. I'm not going to write 2k plus 7. I'm going to multiply it out straight away. So it's going to be 2k plus 14. And that's my brother, so I've got to do this quick. C is equal to 25. And now you just want to solve it. I'm going to close the door. So now you want to do discriminant, so you want to square this thing here. So I'm going to square it out quickly. 4k squared, double the product, so that's going to be 28, double 28. It's 40 plus 16, 56, plus 56k, and then square 14. Bloody hell, square 14. 4 times 4 is 16, 40, 40, and 100. That's 6. That's 9. That's 1. That's my brother calling. Yeah, I'm going to stop here. I'm going to continue the video in a bit.